Hey, what's going on, everybody? My name is Mr. Jackson, and we are diving into our lesson with math relation, where we focus on the R.D.OM. R.D.OM. This is a trademark for our curriculum in regards to how we go about with the powers playbook. This is featuring polynomials. So, if you have your pencil and your paper, your notebook ready to rock and roll, I need you to write this down. R.D.OM. Reps define our mastery. Reps define our mastery. Because nothing becomes yours until you repeat it. And in this playbook, we're studying one of the most important ideas in all algebra. This is powers, exponents, and the levels of thinking. Now, we dive into polynomials. They are not random. They're sentences built in layers, which means they're structured and they're organized thinking. And most importantly, the exponent tells you the power. Now, comparison to any other school that you might be with, sometimes organizations and curriculum that is supported. At Math Relation, we don't guess. It means we don't specialize in bubble culture. We build receipts. So expect yourself to write. If you find yourself saying that's too much, we're not the place for you. We work and we master our work. We built our craft, and that's what makes us excellent. And if you're ready to be excellent, come with receipts. Receipts don't lie. They show you, you know. So write this down. The way we look at things is we're going to have a set of rules. However, rules are plays. Everybody likes to play games. So our games, we're going to come structured, come organized, and we execute. Next time you walk into class, maybe you might have a friend group or your peers. They like to joke, ha ha ha, key. You're the only one that's going to come in focused, discipline, because you have structure. You invest into yourself. You're going to know the difference between an on and off switch. Most kids haven't mastered that, let alone been taught it. They just want to improve each other. But you're going to improve your work because it's your name. It's your business. So every rule you are about to learn, this is going to be between adding, this is going to be subtracting, distributing, and combining like terms. They're not just going to be rules. They are plays. And once you learn to play, you stop hoping and you start executing. So if you are someone who ever felt like math was confusing, fast, and sometimes embarrassing, you are in the right place. We're going to fix all of that. That's exactly why you are here. This is R.D.OM. Welcome to the power. Playbook. Let's get to work. So, first things first, comes down to learning anything, you need to know the words, you need to know the terminology. This is called vocabulary. In lesson one, vocabulary, understanding polynomials and powers, is it starts off with a question. You're going to say, what is it? So in our case, the first thing you're writing down on your paper is what is a polynomial. Now, as you're writing this down, I'll read it out to you. A polynomial is an expression. It's made of terms and it follows two rules. Here's what we're going to be able to show what they follow. In this case, these are what makes of a polynomial. Polynomial consists of numbers, and these numbers are called constants because there's nothing attached to it. It's just a number flat out by itself, like 5, 10, 13, -5. I'm just saying the number itself, which means it's a constant. The next thing you have is a variable. Variable is what you are all familiar seeing now. Is X, Y. The third variable you're going to most likely see would be Z. And it just follows the alphabet, X, Y, Z. There's other letters too, but familiarize yourself with X and Y. Next, you have exponents. Exponents are also whole numbers. You'll see them shown as the power of 2, power of 3, power of 4, and so on. But there's exponents that aren't necessarily shown and revealed to you, which is 0 and 1. We're going to define those. And last but not least, the polynomials, you deal between adding and subtracting between terms. Those will be the only two operations that will be inside of a polynomial. Now, what polynomials do not allow are variables that are in your denominator. So if you were to write on your paper, let's say 1/2, right? That's simply 1/2. Your denominator is your 2. So if you ever see something that says 1/x, this is an example of what polynomials do not allow. That is a variable inside of its denominator. The second thing is you will not see negative exponents. You will see x raised to the power of 2, but you will never see something like 3x raised to the power of -2, 3x negative squared. That is not a polynomial. And last but certainly not least are fractional exponents. So something such as x raised to the power of 4. However, you won't see x raised to the power of 3/4 or x raised to the power of 1/2. That's a different type of math, but that is not polynomials. Instead, what you are going to see is polynomials are designed and they showcase themselves as a math sentence built out of powered terms. Let's write that down. A polynomial is a math sentence built out of powered terms. Now, as you write that, first thing we wrote down was a polynomial. We asked the question what it is. Then we finished with polynomials saying they're built out of powered terms. What is powered? Powered is an exponent, as we were discussing. So one example of that is x raised to the power of 3. And I love power. Power means you're getting stronger. Power means you're getting bigger. Power means you're the largest. You're the biggest. You're the baddest. That's power. How this works is you have x. And x by itself is a coefficient of 1. 1x. That means x is your base and 3 is your exponent. So that's when you're looking at your power. That's 1x raised to the third power. And 1x raised to the third power means I'm going to have x, which is by itself one time, but to the third power means x is being multiplied by itself a total of 3 times, meaning x times x times x. So that's where it goes x cubic, x raised to the third power. In the best case of scenario understanding that is a power means repetition. X times x times x. That's repetition. Just like a beat with a music song. It's just made that repetition. You heard a sound, you heard another one, and then maybe another variation, but there was repetition that kept happening. It repeat, it repeat, it repeat. That's all polynomials and powers consist of. Something that is repeating itself. Now, when you add numbers, this is where you get to the next part. Vocabulary, where you're going to define what is a term. So a term is just simply a variable, a number. Oftentimes you'll see it as a coefficient, but it's just simply what is all being shown and revealed to me when I do not have an addition or a subtraction sign. So in our case, we have 7x raised to the power of 2. 7 is the sole number here. 7 is your coefficient. X is the variable. And 2 is your exponent. That's your power. So if I'm writing this all out, I'm going to say 7x raised to the power of 2. This whole thing by itself is one term. So what creates more than one term is when there's separation between a plus sign and a minus sign. Something's being added or subtracted. So here we have a trinomial. That's 3 terms all together. You have 3x raised to the power of 2 minus 5x plus 5. Plus 9. So 3x squared minus 5x plus 9. All 3 of those individual terms. And you can hear it as I'm speaking it out, which is important. When you're reading numbers, you want to make sure you're saying it out loud. It's going to start to make a little bit better clarity for you. Or even as you're talking to yourself, you're saying it to your head. As you read the number 3x squared minus 5x plus 9. If I take each individual piece apart, you only have 2 different differentiations here, the plus and the minus. Plus stands for positive. So my positive numbers that were shown there as my 2 terms is the first one, 3x squared, and my constant, which is 9. The negative stands with the subtraction sign, which is negative 5x. 3x squared minus 5x. They separated. So it's telling you there are different powers here as well. 3x squared, that's a whole different beast. Negative 5x, that's a whole different animal. And then plus 9, it's just a simple constant. Let's dive in further. Coefficient. Oftentimes, the simplest place is to define this as a number with a variable. But what it truly means is a number is being multiplied by the variable. So even as I said, 3x squared and negative 5x, you have your coefficient, which is your number, and it's being multiplied by that variable which is attached to it. The most simplest case in terms, I love to make this analogy. On one hand, I have peanut butter. On the other hand, I have jelly. When I put them together, it makes a peanut butter jelly sandwich. That means they're stuck together. This is how coefficients read. It's a number being multiplied by the variable. And if your variable has an exponent, if it has additional letters, as long as everything is attached to each other as a term, the number, which is going to be in the very front, is your coefficient. And if there is no number attached, if you see a sole variable, the way you're going to know it is by counting that sole variable. And the only number that is present that represents sole is 1. Just like how I'm standing right here in front of you. There's one Mr. Jackson. There's one math relation. Here's where constants come into play. This is a number without a variable. So that's any number that you can think about, from 1 to negative 5 to 3 million. As long as there's no variable involved and attached, you're looking at a constant number. The next piece you're going to be writing down is exponent. And as we had this defined earlier, an exponent is power. It is your number that represents power. And power shows up in cases that we all see. If I have x raised to the second power, you know that as squared. If I have x raised to the third power, you know that as cubic. Then it starts to get heightened, stronger. Sometimes you look at that and say, complicated. But we're here to make things make sense. So whatever that number is, that is your exponent. And if you just have a variable by itself, just like how I mentioned with sole, that tells you what power it is. So if I have x, that's x raised to the first power because it's just standing alone. That's x by itself, which is its visible power of 1. As mentioning different powers, your highest power is what your exponent is going to be defined by, and this is called a degree. When you have multiple terms that create a polynomial, they're always going to be ranked in chronological order that starts off descending. So you look for your highest exponent. An example we have shown, it says 4x cubed, which is also 4x to the third power, plus x squared minus x plus 1. Your degree is 3 because that's the highest number that's shown as an exponent throughout all three terms, or four in this case, but this polynomial itself, you go with the highest degree. Next, I call this invisible language. It's invisible knowledge. And this piece is what's powerful. As mentioned, X, you see any variable by itself, that can be X, that can be Y, that can be Z. As long as it's a variable standing alone, as mentioned, that's raised to the power of 1. Where you have a constant, that means there's a number by itself. And if we want to get really technical, that means that number did have a power, but that power was taken away. It means there's nothing there, which is a power of 0. Power of 0 means you're only going to be defined by the number that is constant by its own self. In this case, that's 7. 7, you want to be technical, so you know all your terms will be 7. You can say x to the power of 0, because anything raised to the power of 0 is always going to automatically be defined as 1, which is the number that's being standalone. In this case, it'd be a coefficient, but it's a constant. So in terms of power order, you can have x raised to the power of 4, and then you descend. X raised to the power of 3, x raised to the power of 2, x raised to the power of 1. Most of the times, that's it. This is where we get the constants, which is x raised to the power of 0, which is nothing. So it just goes back to what number it is standing all alone. And last but certainly not least, here we go. This is a quick check. I put 30 seconds on the clock. It's gonna take you more, it's gonna take you less. So we're identifying the parts. You're gonna write this down as negative 6x raised to the power of 4 plus 2x squared minus x plus 9. And you're gonna ask 4 questions. First question is, what is the degree? If you need to go back to see what degree is, you see highest exponent. Always look for what's that tiny small number that's shown up top. You're looking for the largest one. In our case, we have 4. The degree is 4. What is the leading term? That's going to help you out to know. Once I know what my highest degree is, I start off with that number. Here we have negative 6x to the power of 4. What is your leading coefficient? You stay back with the same number or the same term that's being focused on, which is negative 6x to the power of 4. Now it says the leading coefficient, so it's the number itself, which is only negative 6. And last but certainly not least, what is the constant? The constant that's being shown here is a number that's by itself. So as you look at all these different terms here, I see an x raised to the power of 4. I see an x raised to the power of 2. I see an x by itself, which means it's raised to the power of 1. And then I have a 9. There's no x here. My constant number would be 9. If you're ready for more, click in on our next video. We're going to dive into addition, subtraction, and combining like terms. Once again, this is the overview of polynomials. They give you lesson 1 of your vocabulary, where you provide the language to the lesson. This is Mr. Jackson with Math Relation. Be sure to follow us on all platforms, social media, LinkedIn, we got Instagram. Everything is revealed as Math Relation. Talk to you soon. See you next video.